Welcome to the Essence World. Today lecture we are going to talk about Ignou June 2019 che-4 physical chemistry. We already discussed question number 1, 2 and 3. In this particular video, we continue with question number 4. This is the question number 4, state chateliers principles. Well, suppose we will take N2 and S2 in a container which is closed in a pistons. If you carefully observe, when we added S2 and N2, it start to react each other and form ammonia. After some time, the reaction is stopped and reach in equilibrium state. Means I would like to say that N2, S2 and NS3 three are present in that containers, but no reaction is occurs. That is our equilibrium state. Let's draw its equation, that is N2 plus 3S2 form ammonia, that is our ammonia gas. This is an exothermic reaction, means it involves heat. Okay, alright, but when we try to disturb our equilibrium state, first of all we require some condition, means I try to take some steps to change my systems. Let's observe the condition to disturb the equilibrium condition. First one is increase pressure. Increase or decrease pressure. Then second one is increase or decrease volume. Third one is temperature. Fourth one is addition of H2. And N2, that is our reactants. Then fifth one is removal of NS3. Then sixth one is addition of water. If you carefully observe what will happen in this particular cases, let's discuss. If we increase or decrease the pressure, if we increase the pressures, equilibrium shift in forward directions. Means more ammonia are formed. If we increase the pressures, the volume also decrease, because we will take a closed pistons. Similarly, if we increase the temperature, reaction is backwards. Means our ammonia is broken and to form N2 and S2. Why this was happened? Because our reaction is an exothermic reaction. Already heat is evolved. So the next one is addition of S2 and N2. If we added S2 and N2, then more ammonia, more NH3 will form. Our reaction is forward reactions. Then last one is the fifth number is removal of ammonia. If we remove ammonia, more nitrogen and hydrogen react each other and form more ammonia. This is also a forward directions. Our equilibrium shifts in forward directions. And the last one is addition of waters. If you will carefully observe what will happen when we added some water in this particular reactions, please check it and comment in the comment sections. Okay, alright. If we added some water, we will already known about ammonia, that is our Na3, is mostly dissolve its waters. So that N2 and S2 react and to form ammonia, and this reaction, our equilibrium shift in forward directions. This is all about Le Chatelier's principles. Well, the definition of Le Chatelier's principle, that is, whenever the equilibrium of a system is disturbed, the position of the equilibrium shift so as to minimize the change. Well, this is the question number 5. Write cell reaction occurring in a Weston cells. Okay, let's draw the diagram of Weston cells. In this particular cases, right side work as a anodes and left side work as a cathodes. In the bottom of the anode, we will take cadmium with Hg, that is our cadmium amalgams. Then we will add CdSO4 with 8/3 H2O, that is our cadmium sulfate with waters. But in cathode sides, we will take mercury, that is our Hg, in the bottom of the Weston cells. Then we will take mercurious sulfate, that is our Hg2SO4, and except these we will add a saturated solution, that is our cadmium sulfate saturated solution in the Weston cells. Then if you carefully observe, oxidation occurs at the anodes. Let's draw the reactions. Oxidation at anode. Oxidation means removal of electrons. Well, in this anode cases, we'll take Cd amalgam, only will take cadmium, that is Cd. When it goes to through oxidations, Cd2 plus and remove 2 electrons. Well, similarly in cathode cases, reduction is occur, means reduction occurring at cathode place. So let's draw the reactions. But in case of cathode, we will consider, that is our Hg2SO4, we will take mercury Hg2SO4, that is our mercurious sulfate instead of mercury. Okay. If we balance these electrons, then we added these 2 electrons. Well, then finally we added both 2 reactions. Our overall reaction is we cancels both electrons because these 2 electrons are present in opposite side of this particular reactions. So if we added, we will get, that is our Cd plus Hg2SO4 2Hg Cd2 plus 2 minus, we also write like this. This is our CdSO4 we also write the final equation, that is our Cd plus This is question number 6, states grothus law. Okay, let's take an examples. We'll take a glass beaker and take some dye inside it. If we incident light when we observe three conditions. First one is some light is transmitted and some light is reflected and some little amount of light is absorbed by the dyes. Well, if the light is absorbed by the systems, it produces chemical reactions. But when the light is reflected or transmitted, it does not produce any chemical reactions. This means that it is not sufficient to pass light through the substance to bring about a chemical reactions, but the light must be absorbed by the systems. When the conditions are not favorable for the molecules to react, the absorbed radiations is re-emitted as heat or light. This re-emitted as heat or light. So we'll write like the definition of Groth-Draper's law, that is, according to Groth-Draper's law, according to this law, only that radiations which are absorbed by reacting substance or system can be effective in producing chemical change reflected or transmitted light does not produce any chemical change. The definition of Groth-Draper's law, that is, according to this law, only that radiation which are absorbed by the reacting substance or systems can be effective in producing chemical change, but reflected or transmitted light does not produce any chemical change. If we discuss its mathematical formula, that is, it's a very easy formula, intensity of absorbed radiations, absorbed light this is our intensity of absorbed light I naught, that is our intensity of incident light, and IT, that is our intensity of transmitted light. This is our mathematical formula to express the Groth-Draper's laws. Well, this question number 7, the Brownian motion of colloidal particles. This is our nice diagram of Brownian motion of colloidal particles. If we discuss its definitions, the random or zigzag motion of colloidal particles in a solution is called Brownian motions or Brownian movement. If we will carefully observe, and the random or zigzag motion colloidal particles in a solution is called Brownian movement. Brownian movement. We also write like this: Brownian motions is a the random movement of particle in a fluid due to their collisions with other atom or molecules. Let's take an example, that is the random motion of dust particles. Random motion of dust particles inside a room. That is our example of Brownian motion of colloidal particles.